Hello and welcome to another one of D's ADD videos. Here we're going to look at an example of this anion Lewis structure. So for step one, calculate all the valence electrons. These are all halogens, so the valence of a halogen is 7. There's 5 of them total, including the iodine. That gives you 35 electrons. Now we have a minus sign, so that means we have 1 extra electron, so that gives you 36 electrons. Because of symmetry, we put iodine in the middle and 5 fluorines outside. Alright, so first thing we do is we have to bond everybody. Oop, I put one too many fluorines in there. Sorry about that. One bond for the peripheral halogens, usually. And if we do that, we get 36 minus 8. And that gives you 28. And if you do 6 lone pairs on each fluorine, and there are 4 of them, 4 times 6 is 24. And that's how many lone pairs I just drew in. But the problem is we had 28 lone pair electrons, so that we have 4 lone pair electrons left over. Well, this is the case of the expanded octet. What you can do is you can add, because of iodine being below the 3rd row, anything on the 3rd row or below has access to the d orbital, so we can have what's called an expanded octet. And in the expanded octet, you basically are able to either form more bonds with the peripheral atoms or add, in this case, lone pair electrons. So 2 there, 2 there, and there's your 4. Now, why wouldn't you want to add extra bonds? Because the peripheral halogens only tend to form 1 bond. It's only if it's central that it forms multiple bonds. So let's see if our formal charges add up. Let's see, the formal charge for iodine. Let's start out with that one. Its valence is 7 minus the 4 bonds, 1, 2, 3, 4, plus the 4 lone pair electrons. 7 minus 8 is -1. So the fluorines, I only have to do 1 of the fluorines because they're all 6 lone paired, 1 bonded fluorines. So it's 7 minus 6 lone pairs, oops, and 1 bond. I did that in backwards order, and that was a horrible 6. So it'd be 1 bond plus 6. A lot of people are tempted to count each one of these bonds. We're just looking at 1 fluorine atom, okay, not all of them. And they all have a neutral charge. 0 plus -1 is -1, and that's what this thing told us it should have been, a net charge of -1. So you put the -1 charge there, and this is a valid structure, Lewis structure, so if you wanted, you could have put a -1 charge out here. Okay? So make sure you check out the other example videos. I'll do one for resonance. I'll do one with multiple bonds instead of lone pairs in the expanded octet. But the most important part is you have to practice as many of these as you can. The key is going to come into play when we start learning VSEPR models and 3-dimensional structures. If you cannot draw Lewis structures, you won't be able to do any of that stuff, okay? So practice these and know them well. Hope I've cleared up any confusion you might have. Thank you and have a nice day.